today we are starting our new unit for Unit 2, and it is on bonds. If you go to your Unit 2 digital notebook, you do see the table of contents. Make sure you put your name and your class block. And then, so the table of contents is for today, or Tuesday, we're going to talk about monatomic ions and simple binary ions. Wednesday, polyatomic and transition metal ionic bonds. Thursday, we're covering covalent bonds, talking about how to name it and how to draw it. Friday, we'll talk about metallic bonds and intermolecular forces. And then the next Monday, crystalline and amorphous, and that's also when we'll review for the test, which you can get by the link or on the very last slide is the review slide. And then there is a lab for the bonds. It is a bonds lab. So that'll be Tuesday the 9th or the 15th. Your notebook check and test will be on Wednesday the 16th as well. So first, we are going to go over ionic bonds. So you all should be on the monatomic ion page. All right, so today your topic is Intro Ionic. Your goal. I can name monatomic ions. Okay, so first off, we need to know what ionic bonds in order to talk about monatomic ions. Bonds are forces that hold groups of atoms together and make them function as a unit. You do need to make sure you type out bonds, underline it or highlight it, and then there is the definition for that. And remember, while you're watching videos, you can pause, stop them, whatever you need to type this out, whether you watch the video full screen, make it bigger just for you to see what's going on, or just go back and forth to write notes, whatever's easier for you to take notes throughout the digital notebook. All right, so the different types of bonds we're going to talk about is ionic bonds, covalent bonds, and then we also talk about metallic bonds. But first, we're going to focus on ionic bonds. Ionic bonds are bonds forming by gaining or losing electrons. It has an octet of electrons, or 8 electrons, in its highest occupied energy level, which we covered a lot last unit with electron configuration and Lewis structures. So basically, metals lose electrons to form positively charged cations, and nonmetals gain electrons to form negatively charged anions. So here's some properties of ionic compounds. The structure has a crystalline solid. It has a generally high melting point, a generally high boiling point. They are excellent conductors of electricity, and they are generally soluble in water, or they mix well with water. So ions. Ions are atoms or groups of atoms with a positive or a negative charge, which means electrons have either been lost or gained. So you do need to make sure you know that. Underline, highlight the word ions, and put the definition. So when an atom or molecule gains or loses electrons, it becomes an ion. A cation has lost electrons, therefore has a positive charge. I know it's kind of opposite, but since electrons have a negative charge, the fewer you have, the more positive it's going to be. An anion has gained electrons and therefore has a negative charge because it has more electrons than what it typically has. So you do need to make sure you typed out cation and anion and know those definitions. To tell the difference between a cation and an anion, you can look to see if there is a charge in a superscript. So for example, here we have a list. We have Na with a plus, I with a minus, Ca with a plus 2, O with a minus 2, and then we just have Na, I, Ca, and O. Which are the ions? Well, the ions are the ones with a positive or negative sign or a number. If there's not a number, it's just assumed to be 1. So like Na with a plus, you may see a +1, you may just see a plus sign, but it is the same thing. So anions are ones with negative charges. So in this case, looking at the list up top, I with the negative charge and the O with the -2 charge are your anions because they are negative. Cations are the ones with the positive charge, so that would be your Na with the plus sign and your Ca with the +2. Now the ones that are just regular elements are the ones that have no charge at all, so that's everything on that second row, the Na, I, Ca, and O that has no charge listed. Why would an element want to lose or gain electrons? Well, it's because they want to be stable. They want to be an octet, which means that there are 8 electrons in the outermost shell in order to be happy. So charges on common ions, if it's in this first column, it has a +1 charge. That's your hydrogens, lithiums, sodiums, potassiums, so on and so forth. If it's in the second column, your berylliums, magnesiums, calciums, those are +2. We are going to skip the transition metals for right now. We'll talk about those later on in the unit. If it's in the column with boron, aluminum, gallium, indium, and thallium, then it has a +3 charge. So those are the columns with the positive charges over here. If it's a metal, or if it's on this side of the periodic table, it will have a positive charge. In the next column, it can be either a positive or a -4. Now this, you don't see very many ionic bonds occurring with these columns, so you typically don't hear a lot about things having positive or -4 charges just because it's not as common, but that is what the charge would be if it's in that column, depending on what it's bonding with. Okay, the next column with nitrogen, phosphorus, arsenic, antimony, bismuth, and all the way down to the bottom, they have a -3 charge. So now instead of having positive charges, they have a negative charge. The next column will have a -2 charge, which is your oxygens, your sulfur, selenium, tellurium, all that stuff, -2 charge. Then the fluorine, chlorine, bromine, iodine, all those have a -1 charge. Now that leaves the noble gases right here at the very end. They don't have a charge at all, and that's because they already have 8 electrons, so they don't ionically bond with anything because they're already stable, they're already happy. So by gaining or losing electrons, atoms have the same number of electrons as the nearest group 18 atom, which we'll talk about later on when they're actually bonding with other elements. So how would you write the symbol for the sodium ion? So first off, we know sodium is Na. So you will find sodium on the periodic table, which is over here. It's in this first column right here with the hydrogen, so it has a +1 charge. So all you have to do is put +1 as a superscript or as an exponent. All right, so that's it for just the simple now we're going to talk about monatomic ions and how to name them. So first off, you will need to type out how to name them. Simple cations, or ones with positive charges, are named by putting the element and just adding the word ion to it. So for example, K. If you look at K on the periodic table, it's in that first column, so it has a +1 charge. So the only thing you have to do to name that is put potassium and then add the word ion to it. Same with beryllium. It has a +2 charge, so it would just be a beryllium ion. Simple anions, or ones with the negative charges, you add the suffix IDE or "ide." So, for example, if you have N with a -3 charge, N is nitrogen. So you would add the suffix "ide," so it would be nitride. Sulfur has a -2 charge, and so instead of it just being sulfur, it would be sulfide. How do you write the compound from the name? So we just talked about if we see the compound, how to get the name from it. So now we're switching it. What happens if I give you the name? How do you write that compound? So you look at the base word to figure out what element you're talking about. You put the symbol of that element and write the charge next to it as a superscript. So kind of like what we've already talked about. I'm going to be putting in a video of me doing some examples of the monatomic ions for you guys here. So if you have any questions about that, let me know. The practice for this, you have 3 columns. the first one's already filled in. It's the element name. You'll find the element symbol. Then you'll find the ion formula by looking at the charge, which I'll go over with the examples. And then you have the ion name. Remember, if it is a positive charge, you just add the word ion. If it's a negative charge, it ends in IDE.